prestressed concrete beam, the prestressed beam of 250 mm wide and 360 mm deep, 360 mm deep of span 12 meter is is reinforced with tendons of area 350 mm square with an eccentricity of 60 mm. Full stop. The initial prestressing force, the initial prestressing force is 1250 Newton per mm square. Find percentage loss. Find percentage loss if the beam is A, pretension, if the beam is pretension, and B, if it is post tension. Okay, full stop. Take ES is equal to, ES means Young's modulus of steel. It is 210 kilonewton per mm square. EC is equal to Young's modulus of concrete, modulus of elasticity of concrete. It is 35 kilonewton per mm square. It is 35 kilonewton per mm square. Okay, full stop. The creep strain, the creep strain for post tension, the creep strain for pretension and post tension beam, post tension beam is so for pretension it is 45 into 10 raised to minus 6 and post tension 22 into 10 raised to minus 6 respectively. Shrinkage strain is 215 into 10 raised to minus 6 and 300 into 10 raised to minus 6 for pre-tension and post-tension beam respectively. Respectively. Full stop. The relaxation loss is is 5% and anchorage slip is 1.25 mm. Anchorage slip is 1.25 mm. And the coefficient the friction coefficient K is equal to it is 0.0015 per meter. So this is the given numerical. First we will see it. A prestressed beam of 250 mm wide and 360 mm deep of span 12 meter is reinforced with the tendons of area 350 mm square. So B is given, D is given, overall depth is given, L is given, span is given to you, AST is given, area of steel is given to you. The value of eccentricity is also given. Okay, E is also known to us. The initial prestressing force is 1250. So the value of P is also given. Okay, so the initial prestressing force, let it be, we call it as P0. The initial or PI. PI stands for initial prestressing force 1250. Find the percentage loss if the beam is pre-tension or the beam is post-tension. First we need to find out all the losses for pre-tension beam. After that we need to find out all the losses for post-tension beam. Okay. So the values of constants are given over here, ES, EC, then creep strain is given, then shrinkage strain is also given. Okay, then the relaxation loss percentage is given, anchorage slip, that is delta value, is given, and the friction coefficient, that is, it is not mu, it is K value, is given 0.0015. Okay, so now we need to solve this problem. So we will move further to solve it. So now first, what we will do first? First we will calculate the stress in steel, stress in concrete at the level of steel. Okay, first is stress in concrete. What is the stress in concrete at the level of steel? So this is the notation for this is FC. We use this notation. So which can be calculated as P by A plus PE square by I. Stressing force, stressing force P is equal to, it is stress into area. Okay, so calculate the stressing force first and then calculate the value of FC. Now you know the formula for FC and let me know the values. So what is the stress now? It is 1250 multiplied by what is area, 350. So what will be our force? What will be our force? It is 437.5 kilonewton. Okay, it is 437.5 kilonewton. This is our force. Now Fc is, now put the value P by A and P is square by I. Now P by A, P is 437.5, it is kilonewton, so multiply by 10 raised to 3, or you can take this value is in Newton. If you multiply this, you will directly get the value in Newton. You can take that value too. Okay, so now it is divided by area. So area is 250 into 360 plus again 437.5 into 10 raised to 3 into 60 square divided by I is 250 into 360 cube divided by 12. So now the value is 6.48. Okay, so the value is 6.48 Newton per mm square. This is the stress in concrete at the level of steel. So where the steel reinforcement is placed, at that level the stress in concrete we have found out. What is the stress in concrete? Okay. So after that we will calculate the modular ratio. Okay. After this we will calculate the modular ratio. So now modular ratio M is equal to, it is ES upon EC, Young's modulus of steel divided by concrete. So steel is 210 kilonewton per mm square divided by 35. So what is the value? It is 6. Okay. So this value is 6. So now we will compute the different losses. So first we will take pre-tension beam. So first A, losses in pre-tension beam. Okay. So now for that first loss, first we will calculate shrinkage loss. Okay. Shrinkage loss, which is equal to, so here the shrinkage loss is, you know that the shrinkage loss we will calculate as shrinkage strain, that is ES, shrinkage strain, into Young's modulus, into Young's modulus of steel. So it will be shrinkage strain. Now for pre-tension beam, so what is given, we will see. For pre-tension beam, pre-tension, it is, how much is the given shrinkage is 215 into 10 raised to minus 6. This value is given for pretension. Okay, so 215 into 10 raised to minus 6 into, now ES, how much it is? It is 210 kilonewton per mm square. So multiply by 10 raised to 3. So we will get answer in Newton per mm square. So it is 45.15 Newton per mm square or megapascal. This is your shrinkage loss. Next is creep loss. Okay. So loss due to creep of concrete. So how do we calculate that loss? There are two formulas to calculate that. First, when the this shrinkage creep strain is given, or the second when the creep coefficient is given. So now we will see in the numerical what is given to us. they have given to us that creep coefficient or creep strain. So here if you see, creep strain is given to us. Okay, creep strain is given to us, creep coefficient is not given to us. Okay, if the creep coefficient is given, then your formula is m into phi into c, where m is the modular ratio, phi is the creep strain, and fc is the stress in concrete at the level of steel. Okay, but strain is here, creep coefficient is not given, phi is the creep coefficient, instead of creep strain is given. So now we will use the second formula, which includes creep strain. So now here your formula will be EC, that is the creep strain, into stress in concrete at the level of steel FC into ES. So it will become, what is the value? I forgot that. ES 45 into 10 raised to minus 6. So it is 45 into 10 raised to minus 6 into FC we have just calculated 6.48. 6.48 into ES, you know this value, 210 into 10 raised to 3. Okay. So again, after solving this, we will get the answer. Answer is 61.23. So this is 61.23 Newton per mm square. So this is the creep loss. Then next is the loss due to elastic shortening. Okay. Third loss. It is due to elastic shortening. So this loss is calculated as m into fc. Okay, so which is equal to m is 6 into fc is 6.48. So you will get the answer. It is 38.88. 38.88 Newton per mm square. And now the last thing is relaxation loss. Relaxation loss, this is also called as creep of steel or shrinkage of steel, sorry, not creep. So relaxation loss, it is 5% of initial stress input. So it is given as 5%. Okay, I will write here 5% of initial pre-stress. Okay, so 5% of initial pre-stress, so which is equal to 5% means 5 divided by 100 into what is our initial pre-stress, 1250. So 5% of that, it is 62.5. 62.5 Newton per mm square. Okay, so these are the losses which occur in pre-tension member. In pre-tension member, loss due to anchorage slip is 0 and loss due to friction is also 0, or curvature loss. We called it as a curvature loss or friction loss. That is also 0. So we will not take those losses. So now total loss is equal to, total loss is equal to, so now calculate this total loss. It is 45.15 plus 61.23 plus 38.88 plus 62.5. So the total losses, it is 207.76 Newton per mm square. Now what is the percentage loss? What is the percentage loss? So the percentage loss percentage loss is equal to 207.76 divided by 1250 into 100, which is equal to, that is 16.62%. This is the percentage loss. This is the percentage loss in pre-tension member. Okay. Now we will move to the loss in post-tension member. Loss in post-tension beam. So now we will calculate it one by one. Again, first shrinkage loss. First is the shrinkage loss. So what is the shrinkage loss? That is shrinkage strain into Young's modulus of steel. Now we will take the values directly. What is the shrinkage strain? 300 into 10 raised to minus 6. So it is 300 into 10 raised to minus 6 into 210 into 10 raised to 3. Solve this now. What is the answer? 300 e minus 6. So 63 is the answer. 63 Newton per mm square. Okay. So this is 63 Newton per mm square. Now after this, what we will calculate? Next, same thing, creep loss. The creep loss, which is equal to. So again, it is. We should see what is the creep strain given. So it is given 22 into 10 raised to minus 6. So it is 22 into 10 raised to minus 6 into FC, it is 6.48 into 210 into 10 raised to 3. So you will get the answer if you solve this. 29.93 Newton per mm square. Okay. So now shrinkage is over, creep is over. Now loss due to elastic shortening, it is 0. Okay. In post tension members, loss due to elastic shortening is 0. If it is pulled simultaneously, then it is 0. If one by one wire is pulled, then the loss will exist. Okay, but here nothing is mentioned, though the tendons are pulled simultaneously or those are pulled successively. So therefore, we have assumed that those are pulled simultaneously, and that is why we will take the loss for the elastic shortening, it is 0. Okay, so elastic shortening loss is 0 over here. Now fourth one is the due to relaxation of steel. Okay. So due to the relaxation of steel, It will be same 5% of initial stress. So this we have already calculated 62.5 Newton per mm square. Next is loss due to anchorage slip. Loss due to anchorage slip. Okay. So we know the formula delta is equal to PL upon A. So P by A is nothing but stress, that is sigma. So it will become delta is equal to sigma L upon E. So for sigma, what is your formula? It is delta by L into E. See, I will tell you here. We know that delta is equal to what? It is PL upon A. P by A means what? It is sigma. So this will become delta is equal to sigma L upon E. And now therefore, if I want to calculate this stress sigma, then it is delta into E divided by L. Okay. So here loss due to anchorage slip, it is delta divided by L into ES. Okay. So now anchorage slip, which is equal to, what is the value of this delta? It is 1.25 divided by L. L is the span. Span is 12 into 10 raised to 3. 12-meter span is given into years 210 into 10 raised to 3. Is 21.87 Newton per mm square. So the loss due to the anchorage slip is 21.87. Then last one, sixth one, loss due to friction, that is your curvature effect, which is equal to, this can be calculated as mu alpha plus kx into initial prestress. Okay, so here the value of mu is not given, alpha is also not given, so we will assume it as a 0. So we will take this as kx into initial prestress, so which is equal to, the value of k is 0.0015 into x. It is per meter. 0.0015 is per meter. So we will take x means span, that is length in meter, and multiply it by 1250. The answer is, everybody do it fast, 22.5. Okay, so it is 22.5 Newton per mm square. So this is the last loss. Then we will calculate the total loss. Total loss is equal to, so what is the total loss now? It is 63, that is due to shrinkage. Then due to creep, it is 29.93. Please check the values. If there is any correction, then let me know at this time only. So due to creep, this is the loss. Then elastic shortening, it is 0. Then relaxation of steel, it is 62.5. Then plus it is anchorage. Anchorage is 21.87, and plus curvature effect, it is 22.5. So if you add all these, you will get the total loss. 199.86. Please check the value. Okay. So the percentage loss, which is equal to 199.86 divided by 1250 into 100. So 15.98%. This is the percentage loss. Okay. And if they have asked you further, what is the final pre-stressing force in this post-tension member and pre-tension member, what you will do further? Now if they ask you to calculate the final pre-stressing force, then what you should do? You are having the initial pre-stressing force, the value of your initial. So final pre-stress, if they told you to, if they ask you to calculate final pre-stress, so initial pre-stress is 1250. Okay, this is your initial pre-stress. Now what is the loss? Loss is 199.86. So from initial, if you minus this loss, total loss, then you will get the final pre-stress. Okay, so here I will write final pre-stress. हे विचारलेलं नाहीये पण तरी तुम्हाला सांगतोय. Final pre-stress in we can say post tension beam, in post tension beam is equal to, what is the initial pre-stress? Initial pre-stress is 1250 minus loss किती झाला याच्यातनं तर 199.86. This is the loss. So here if you calculate, then it will be round about how much? 1250 minus 200, near about. It is 1050.14. 1050.14 Newton per mm square. Similarly, you can calculate. Similarly, now you can calculate this final pre-stress for pre-tension beam also. So for pre-tension beam again, this 1250 will be, it is constant, but minus this loss will get changed. Whatever may be the loss there we have calculated, you need to subtract this loss. Okay. So this is the last type of problem in this unit. So mainly if the written examination is there, then from this unit this type of problem is asked, where in the single problem you are calculating all the losses, okay, for both retentioning and post tensioning beams. Okay. So with this last example we will end our unit losses in stress over here. In the next lecture we will start with the next unit, design of stress sections. Okay, so we will design the stress sections for your syllabus. I think rectangular sections are there, so we will design those, and one problem of I section, one problem of rectangular section. These two sections are there for your syllabus. Okay, so we will stop over here for today.